Hello, grade 8. How are you today? I hope you all are safe and well. We studied before about properties of magnets, and we studied the magnetic field, and we said the region where magnetic materials experience a force is called a magnetic field. And we can find the shape of a magnetic field using iron filing or plotting compass, which is the small compass. And we said that the Earth behaves as if it has a bar magnet inside it. So today we will learn about electromagnet. Electromagnet is the word comes from electric or electricity and magnet. So how can we use electricity with a magnet, or and we will find out is it going to be a strong magnet or weak magnet? Does it affect this electricity? Does it affect the strength of this magnet or not? And how can we switch it off and on using the current or using the electricity? So open your books on page 140. Grab your highlighters and follow me, please. Electromagnets. Switching magnets on and off. A bar magnet is a permanent magnet. You can switch it off without demagnetizing it completely. You can make a magnet that you can switch on and off using a coil of wire and a battery. It's called an electromagnet. So the magnet or the bar magnet, the ordinary one, it's a permanent. We cannot switch it off. We cannot stop the magnetism without demagnetize it completely, which is like hitting it or breaking the pieces or any way possible to demagnetize it. So we can use another way to switch off and on this magnet by using a coil of wire, which is wrap a wire around a magnet or around a piece of iron, and use a battery with it, and this called electromagnet. We can magnetize it and demagnetize it. The field around the wire. So what about the field around the wire? We said that the magnetized or the magnetism field or the magnetic field around a bar magnet will go from the North Pole to the South Pole, or from the north side to the south side. So what about the field around the wire? Electromagnets work because when an electric current flows through a wire, a magnetic field is produced. So that's why the electromagnet works. So it works because when you connect it with the battery, the flow or the electric current will flow through this wire. Around this wire, there is a magnetic field is produced there. You can use plotting compass to draw the field around a single piece of wire. I showed you a video about how can you use a plotting compass and track the North Pole, where does it point, or points where to, and just place dots, then connect it in the video that I showed you last time. So you can use the same method or the same way or the same thing with using electromagnet around the wire. The magnetic field lines around the wire are circles, so like this here. Last time we saw it as an oval shape and it's moving from one place to another, but here around the wire we can see it as circles. The magnetic field gets weaker as you get further away from the wire. So in the bar magnet, as we go further away from the bar magnet, the magnetic field is getting weaker and weaker. Here is the same thing but with the wire. If we went away, or if we get away or further away from the wire, the electric field, the magnetic field, sorry, is getting weaker and weaker. Now, let's see how to make an electromagnet. You can make a circular loop of wire and pass a current through it. The magnetic field lines at the center are straight. So we can use a battery, a nail, iron nail, as you can see here in this picture. This is the battery here. This is the battery. This is the switch. We can switch it on and off. And we should connect it to a nail, iron nail. And here are the wire, which is like we should wrap the wire or coil the wire around a nail. But we need to use insulated wire, which is like coated with plastic, like the wire that we are using for electricity. If you use the copper wire, you can do this by using copper wire. The nail will act like a magnet if we pass this current through the wire using this battery and switch. So you can coil a wire into lots of loops and make a coiled cylinder like this shape. This is coiled cylinder. When you pass an electric current through the coil, a magnetic field is produced. It has a similar shape to the field around a bar magnet, like you can see here. It goes from the north to the south, from north to the south. Okay, so here it's similar to the one around the bar magnet. Coiling the wire concentrates the magnetic field inside the loops, so the field is much stronger than for a single loop on its own. A coil of wire is called solenoid. So here, if we coil the wire, this coiling will concentrate the magnetic field inside the wire, and it will pull, or it will be stronger than a single loop. So if we start to wrap the wire around it many times, or we created many coils, as more as we are increasing the coils, the more electricity will pass through it, and more a higher magnetic field or stronger magnetic field. So a coil of wire, we call it solenoid, as I said. To make an electromagnet, you use a coil with some magnetic material called a core in the center. The core becomes magnetized by the magnetic field of the coil. This makes the electromagnet much stronger. Most cores are made of iron. The core here is the nail, or we can use piece of iron, piece of steel, any magnetic material. We can use any magnetic material such as iron. Most of these cores made of iron, anything like cores means something in the center, okay, in the center of anything, like the liquid core of the earth or the solid core of the earth. So here the core is the iron. So if we want to make this electromagnet, we need to use piece of magnetic material, and we need to coil a wire around it and connect it to a battery and switch it on and off. And in this way we can use it. The electricity will flow through, or the current will flow through this wire, and will create or produce a magnetic field around it. The switch turns the electromagnet on and off because the magnetic field is only produced when a current is flowing in the wire. So without this current flowing, we cannot use it as a magnet. This is a magnetic material, but it's not a magnet. So it can only be produced by this current or electric current. That's why we call it electromagnet. The inner core doesn't remain magnetized when you turn the electromagnet off. So once you turned the switch off, which is like open the switch like this way, like open it, the iron nail will stop being magnetized. So it will be just a nail, just iron nail without any magnetic properties. But if we closed it like this, if we closed the switch, let me show you like this. If we close the switch like this, that means we are connecting the circuit, so the electricity will flow from the battery to the switch to the wire here and to the nail. So the nail will be magnetized, and magnetic field will be produced, and the nail will be magnetized, and it will act or behave like a magnet. What about the strength of this electromagnet? Is it strong, or any electromagnet is it strong as the or weak as the bar magnet? The strength of an electromagnet depends on, so it depends on many factors. The number of turns or loops on the coil. So as I said, as more as we coil the wire on the core, the more the nail or the core gets stronger. More turns will make a stronger electromagnet. Second factor, the current flowing in the wire. So more current will make a stronger electromagnet. So if we used a battery, strong battery, like 12 volts, it will produce more or stronger electromagnet than if we used a battery of 1.5 volts. Here, the type of core, this is the third factor. The type of core. Using a magnetic material in the core will make a stronger electromagnet. So there is a difference if we used a core made of iron and we used another one, non-magnetic material. So here, the core of the that made from the iron or copper, it will be it will produce a stronger electromagnet or electromagnetic field. The current flowing in the wire depends on the power supply and the type of wire that is used in electromagnet. So sometimes we have good conductors of electricity, like materials that could conduct electricity more, and we have less ones. So if we use the good conductors, this can produce stronger electromagnet. And also the power supply, like as I said, the battery strength or the battery's volt. What about the permanent magnets and electromagnets? There are two main differences between a permanent magnet and an electromagnet. So they are not the same. We have permanent magnets like the bar magnet, and we have electromagnets. So what's the difference between them? You can turn an electromagnet on and off, but we cannot do this for the permanent magnet unless we demagnetize it completely. We just make it as a piece of material, not a magnet. And you can make an electromagnet that is much stronger than a permanent magnet. A permanent magnet, we can use it for the fridge stickers or decoration. We can use it on the whiteboards. We can use it to pick up nails or something. But electromagnet, we can make it much stronger. You have here in this picture a crane. This crane can hold, it's very, very strong. It can pull a car. It can attract an iron or steel car, because once it's switched on, it will pull anything made of magnetic material, like such as iron. You can see here like the frames or the center of the wheels, the iron piece of the wheels. We have here rubbish like pieces of iron, broken magnetic material. They are picking them up using this crane. So once the man here in the inside the machine or switch it on, it will start to pull everything made of magnetic material up, and if he switched it off, everything will be down. This makes electromagnets very useful. They can be used to move large pieces of iron or steel in a factory. So they can use it in the car factories. How can they transfer the car body from one place to another? By using electromagnet. Or to move cars in scrapyard. So this is the scrapyard. They can move cars or pieces of cars. When the current is turned off, the electromagnet drops the car. So that's how can they move, the cars from one place to another. Doctors can use a small electromagnet to remove iron or steel splinters from people's eyes. So if some people got injured because of iron pieces of steel, doctors can remove them using a small electromagnet to attract these pieces of iron or steel to them, and remove them from the people's eyes. So now let's go to the summary of the lesson. Electromagnets. A current flowing through a wire produces a magnetic field. An electromagnet is a coil of wire usually wrapped around an iron core. You can switch an electromagnet on and off by turning the current on and off. The magnetic field around an electromagnet is similar to that around a bar magnet. So this was all about electromagnets. I hope you understood the lesson. If you have any question, write it down, and don't forget to write these notes in your notebooks. Please don't forget the yellow box homework, and see you soon next time. And we will meet in a new lesson. Bye bye.